Welcome to the Commerce Tomorrow podcast, your one stop to learn about the technology that's powering the future of commerce. Here are your hosts, Dirk and Kelly.
Welcome to another episode of the Commerce Tomorrow podcast. I'm your host, Kelly Gage, and unfortunately, my co-host, Dirk, cannot join today because he is sick. Today, we're joined by Bob Gregory. He's Chief Architect of Cazoo. Welcome.
Right, thank you very much.
And just for full disclosure, Cazoo is a customer of Commerce Tools, but we thought that Bob and Cazoo were doing some really interesting things, so we thought it'd be worthwhile to have him as a guest. So, Bob, do you want to start by giving us a personal intro, your career to date, and then we'll talk a little bit about Cazoo quick before we get to serverless?
Okay, so I'm Bob. I'm a software architect. I'm currently at Cazoo. Before that, I was the architect for a company called Made.com, and then before that, I was at a company called Huddle. So I've been in architectural roles for about 12 years, building these kind of event-driven, distributed microservice setups. I'm a self-taught programmer. My first and most recent language is JavaScript, but I've also written a lot of .NET, I've done some Java, and I've just published a book about Python with O'Reilly. So I've sort of been around a bit.
Wow, good background. And what is Cazoo for those who are not in the UK?
Yeah, Cazoo is a new e-commerce company. So we're a used car retailer. We're not an aggregator like Auto Trader or something. We own all of our stock. It's all in a massive car park in the Midlands. We buy cars from auctions or what have you, and then we put them through a 150-point inspection process to make sure they're good quality. And we sell them online like any other kind of online e-commerce website. And then we deliver them to your house 72 hours later with a money-back guarantee. So if you're in the US, it's a lot like Carvana, but it's sort of a new play in the UK market.
Interesting. And just, I don't know if it's possible for you to disclose this, but what type of volume do you do a year, just so our listeners can get an idea of the scale of your platform?
So we launched fully in December, so I can't really tell you at the moment, but suffice to say that sales are going better than we expected, and we expect to be a very large company indeed in a year's time.
Cool. Very exciting. Good market to be in.
Mm.
So let's dig deep on serverless. Can you give us a short summary quick on what serverless is?
Yeah, okay. So this is a controversial topic, but I think serverless is a doctrine. It's a set of operating principles. And the kind of fundamental doctrine of serverless is that I don't want to run it if you can run it better for me. So we see most mature organizations kind of procure a lot of their supporting services. Like you can argue about the merits of Microsoft or the NHS kind of outsourcing their cleaning, but it is economically efficient because it means that organization can focus on what they're good at rather than trying to be generalists. So every large organization is now in the business of procuring services from other companies, like third-party logistics or marketing partners and things. And serverless, I think, is about adopting that service-first mindset into our engineering practices and choosing not to build stuff that we're not choosing to differentiate on. So Cazoo, we differentiate on the quality of our cars and kind of the ease of use of our customer experience. We don't differentiate on our support for TLS v1.2 or our fantastically tuned fleet of Jenkins suites. That stuff's kind of irrelevant to our customer base, and so we want to outsource it wherever possible.
Okay. And what are some good use cases in the commerce space? So where would you use serverless versus a standalone service of some sort?
Yeah, so I mean, our entire proposition at this point is built with serverless, right? So I think that you can do most line of business things this way. The kind of two most obvious candidates, the kind of low-hanging fruit for serverless are kind of data processing pipelines and HTTP services. Both of those are very straightforward because, importantly, they're already stateless units of work that have well-defined boundaries. So like an HTTP handler receives a single request and returns one response. Like a pipeline usually gets some input and then writes some output somewhere. So they're already very tightly bounded things that do one job. And I think the hardest thing about moving to function as a service is thinking in those terms of these kind of fine-grained single use cases.
Right. So when I was at reInvent, AWS reInvent, when they launched Lambda, and the classic use case that they gave was somebody uploads a product image to S3, and then these little Lambda functions then go out and resize it in different sizes. So you create a small,
Yeah.
medium, and large version of that, right?
Mhm.
So what are some other good use cases? Little granular pieces of functionality, and I guess what's too big and what's too small for a I shouldn't say Lambda function, but for a function. And also, do you call how do you distinguish between serverless? Right, serverless is more the doctrine, and function as a service is the implementation. Or
Mhm.
maybe you can give a little clarity on that for our listeners.
Yeah, so I think that function as a service is kind of the bleeding edge of this kind of serverless thinking, right? So I mean, Lambda means that I no longer have to care about where my code physically runs, and all the kind of headspace that was dedicated to operating systems and servers and patches and all that stuff is just gone. There's kind of the code that I'm writing, which is designed to affect the metrics on which we differentiate. And then there's just homogeneous, commoditized infrastructure that exists somewhere on the edge of my awareness, right? So function as a service enables that kind of those serverless practices. That means that I don't have to care about a whole class of stuff that Amazon could do much better than I can. I was saying that I think serverlessness or servicefulness, I guess, is a spectrum. So one far end is Lambda, DynamoDB, and those kind of pay-per-use API-driven systems. And then at the other end, you've got your EC2 and RDS, where you've still got a lot of stuff to look after. And in the middle somewhere, there's kind of hosted Kubernetes clusters and Fargate and all that kind of stuff.
Right. And what's the origin story? Do you happen to know anything about where this really came out of? Because for a long time we've had PaaS, right? We've had Heroku since I don't know the mid 2000s roughly, right? We've had this whole concept of like I'm going to do a unit of work and outsource it to someone basically, right? Because I don't want to do that in house.
Mm-hmm.
So how do you differentiate between like a PaaS and then what's the origin of the serverless world that we see today?
So I think the serverless story really starts in kind of the mid noughties with like Zimkey, which was a managed Node.js platform. And in 2008, there's Google App Engine. That was a fully managed service that ran restricted workloads in response to web requests for up to 60 seconds. You had no ability to write files to local storage, you had no servers, no real knowledge of the surrounding environment, but you were able to scale automatically and it was kind of pay per use. I think that the market wasn't ready for that. And instead, they kind of coalesced around EC2. And obviously, Google ended up playing catch up. And then over time, Amazon added all of these kind of back-end as a service things, right? So S3 and SQS and DynamoDB, all these things that you could use in your infrastructure in place of something self-hosted. But I suspect that what happened is people kept asking for little features. The prime use case, when I upload a file to S3, I want to create a thumbnail. Or when somebody inserts something into this particular DynamoDB table, I want to send an email, whatever it might be. This kind of if this then that kind of functionality. And I think they just got sick and tired of fielding endless feature requests and said, just go and build it yourselves. But what's interesting is that Lambda, I think, was originally intended as glue between these kind of back-end as a service things. I think it is more than that, but because it was intended as this glue, it kind of enables new use cases on their existing tool sets. So I can use Lambda to process a change stream out of Dynamo and compute aggregations, for example. Or I can use Lambda to assert compliance with governance policies when AWS config detects a change. Or I can use Lambda to automatically instrument another Lambda function whenever something gets deployed. So all these kind of cases, they let me make the platform richer by virtue of the fact that I can script things in response to events elsewhere in my infrastructure. I think the difference between serverless and the PaaS, Adrian Coburn, I think, said, if your PaaS can scale up new instances of your application in 20 milliseconds and run them for half a second and throw them away efficiently, then your PaaS is a serverless. It's granularity, right?
It's pretty
Um,
stringent requirements right there, but yeah.
yeah, but that's what Lambda does, right? So the other night, literally last night, we had our second TV ad come out on the TV in the UK, and our traffic went up 2 orders of magnitude in 90 seconds, and nothing dropped.
Wow.
Latency was rock solid. We had no increase in error rate. We literally went from, like a very small number of requests, like a few hundred users, to 30,000 odd requests in a minute, and everything was absolutely fine. We didn't have any tin lying around just ready to go. Amazon just scaled us up, and then when it stopped, they scaled us down, and we didn't even see it. That offers a tremendous amount of value, and it changes the way that you think about operational workloads.
Right. Yeah, that's pretty impressive. One issue with various implementations has been the cold start time.
Mm-hmm.
What are you seeing now? What's the state of the art? So is it 20 milliseconds, or how fast are you able to see these things spin up behind the scenes?
Yeah, so it's sub 100 milliseconds for the kind of things we're deploying, which is JavaScript. So Node.js has a very good startup time, as does Python. If you're running Java or C Sharp, then it might be more of a problem. I think there are two things to say on that. The first is that in practice, at my previous gig, which was also an e-commerce company, most things were being served out of cache, and it wasn't uncommon to see first renders of like a catalog page that would take a second and a half, for example. In
Hmm.
which case, cold start probably isn't going to make a massive amount of difference. The other thing to say on that is that Amazon recently brought out provision concurrency, so that you can say, I want to have 5, 10, 100, whatever it is, instances of my application ready to go at all times. So you do then pay for the amount of time that they're provisioned. So it changes the billing model from pay-per-use to like a kind of hybrid model of aggregate, where you have some stuff that's pay-per-use and some stuff that's provisioned on demand. That then means you don't necessarily get those that tail latency for cold starts.
Okay, interesting. So I have a philosophical question, and maybe this would be best done over beers at a pub or something. But are all serverless functions microservices then by definition?
No. So this is a personal bugbear of mine. Um, so I tend not to use the word microservices unless I'm hustling people. So like if I'm pitching a talk or I'm giving a bio at the beginning of a podcast, then it's microservices because it's good advertising. Um, but at work, I talk about event-driven, service-oriented architectures. I think in the olden days, before my beard started to go grey, we used to talk about business capabilities, which is a thing that your organization can do. So, we buy cars at auction, we deliver cars to your house, we sell cars online. These are business capabilities. And you build a service to support a business capability. And a service might comprise many autonomous components. An autonomous component is a thing that you could, if you wanted to, deploy individually or restart by itself. So a database, an event processor, an API endpoint, these are autonomous components. Um, when we're working in Lambda, I like to have one Lambda function per use case. So use case might be add to cart, or it might be, start checkout process, whatever it is. These are use cases, and that's what we model our functions around. But then the service boundary comprises multiple use cases, right? So like the checkout service has add to cart, start process, submit payment, whatever it might be. We
Hmm.
deploy all of those things together, because otherwise what you end up with is people try to break things down to the degree that their quote unquote services no longer have any autonomy, right? I speak to a lot of people in interviews and they're like, oh yeah, we have these microservices and I've got all these different things and they all share this one database. And I'm like, how do you deploy them? And they're like, oh, we just deploy them all at the same time. If you're doing that, you don't have microservices, right? And like by definition,
Right.
services are autonomous. So I think that serverless functions are autonomous components that together in aggregate make up some service boundary. So at Kazoo, we may have maybe 10 functions in a service, and we deploy that whole chunk of functionality together because we want to test against that kind of single published contract.
Okay, so it's 10 functions. Interesting. So you can have a pretty long in terms of number of lines of code service then, right?
Yeah, absolutely.
Interesting. Okay. And where are some limits for serverless just generally? What are some use cases that probably shouldn't be tried using this new approach?
Yeah, so at the moment, there are reasonably stringent limits on like memory and runtime for Lambda specifically. So for function as a service, anything that needs to run for a long time or use a lot of RAM is probably out of the question. But there's things like Fargate where you can run containers on pay per use, metered by the second. Um, and I think that we'll start to see more niche plays, right? So Google AI platform is essentially serverless AI, where they'll train your model for you and they'll run it for you, and it's metered access. You don't have to think about the instances or any of that stuff. It's just they're providing resource and an SDK for you to do these kind of long-running, chunky, computationally heavy workloads that wouldn't be amenable to something like Lambda. So I think as serverless matures, I think more and more things will become amenable to it. But certainly, I know there are domains where, um, for compliance reasons, it would be difficult to convince the auditors that everything was okay if you just tell them, "Oh, my code just runs in ephemeral bits of compute that are scattered all over the internet." Right? That's not going to go down well with some kind of auditors.
Yeah, right. Exactly. They're still stuck in the 90s.
Hmm.
All right. So you group multiple functions then in the same um, serverless function, right? So they're a little bit larger than normal. So let's say you have, and I know, we try to put up boundaries between services, right? But let's
Hmm.
say there are dependencies. I'll give you a really simple one. One that checks for an updated product image. And then if there is one that's passed to another function that then makes multiple lower resolution copies of that image. So right there you have one that does the checking. You also have one that does the resizing, right?
Hmm.
And maybe you have another one that then uploads it somewhere, right?
Yeah.
So how do you chain together those, or would you just say, you know what, those should all be in the same service?
I think that sounds like one service, right? Because the what is the contract that you're expressing to the rest of your organization? If the contract is when you upload a product image, we will put thumbnailed product images in the correct place. That's a contract. And it might be that you have 3 or 4 distinct functions within a single system that are responsible for collectively making that happen, right?
Hmm.
So I would still have a single function per use case. So maybe one that does the checking and then puts something on an SQS queue if it needs to be resized, and then one for each sizer or whatever that can run in parallel. And then maybe a final function that when you write all of those images to the final bucket location can raise an event bridge event to say, product image is resized. And then other systems can just listen to that event, that kind of high level domain language event, um, rather than needing to care about S3 buckets or SNS topics or any of that rubbish. You can just use these kind of high level uh, business language events for communicating between services.
Yeah, I like that a lot. And let's let's look out, right? So you have 200, 300, 400 of these things in
Mhm.
production, right? And number of them. How do you manage their life cycles, right? So there's building, there's versioning, there's deploying, there's testing, right? There's a whole life cycle here that has to be changed to
Yeah.
support this new world. How do you do that at scale?
I think it's actually one of the strengths of serverless. So I think the first thing is you need to have some framework for doing it. So I occasionally talk to people and they're like, "Oh yeah, I just build my code and I put it in a zip file and I upload it with Terraform." And I'm like, "Wow, you're crazy. That sounds like a complete nightmare." Um, because there is tooling out there. So like the serverless framework is the big one, serverless.com. Amazon have one with the serverless application manager. Um, there's like the CDK. So there are these tools that make this job much easier. So we use a serverless framework, And with that, you can literally, in 30 seconds, build a Hello World application. And then from your command line, you type serverless deploy, and it just goes into the cloud, and it's done. So we I wrote an app a couple of months ago, which was to support some testing activities we were doing. So what it does, we use a lot of these EventBridge events, and what it does is it subscribes to all our EventBridge events, and it makes them available to us over a WebSocket. And the advantage to that is that in my acceptance tests, I can then call an API or something, and then I can block waiting for an event to come through the WebSocket, right? So it means these kind of asynchronous workflows I can now test in my normal end-to-end tests. And to get this to work, I needed to deploy like 3 or 4 functions and a Dynamo table and like some WebSocket stuff and a whole bunch of IAM policies. And I basically wrote this on the train, and then I got into work and I sat at my desk and I typed serverless deploy, and 3 minutes later it was all up. And
Wow.
if I'd had to go to an ops team and say, I need a database and we need some passwords and we need to figure out where it goes into VPCs and which environment does it go in, and it just never would have happened because there's so much cognitive load for getting something into production that it would have taken me weeks and months to get there just because I would have had to talk to so many people, right?
Yep.
So being able to just spin it all up from scratch from a single file makes that much, much easier. It makes it much simpler to experiment. We run workshops, for example, for new developers, where non-technical users by the end of an hour and a half session have deployed Lambda functions and they're merrily going away and diagnosing problems with them. So I think this is actually one of the strengths, is that so long as you have the right tooling in place, it is very, very easy to move something into your AWS account or your Google Cloud account or whatever, and then to automate that through a CI process.
Yeah. No, I like that. It does take some change though, right? We've been used to this old approach now for decades, and I think as an
Yeah,
industry we're growing up and maturing, and this is the next evolution in that step.
yeah. I think the big shift I think is that we had servers and that was fine, and then we virtualized them because servers were a pain. So then we had VMs and that was fine, and then they were too heavy, so we created containers and that was fine. But I think every step of that process, we were essentially lifting and shifting existing applications and existing architectures. But with functions as a service, you can't do that. With functions as a service, you need to rewrite things from scratch to fit into this new paradigm, where
Yeah.
you have these very fine-grained use cases, and then you're relying on the infrastructure itself to provide the kind of glue between them.
Yeah. No, I like that. Do you know much about the different offerings offered by the different clouds? So you have Lambda, you have Google Cloud Functions, you have Azure Functions. Any quick thoughts on their scope and maturity and things like that? Or
So I am quite AWS centric. I know that Azure Functions have got some really interesting stuff. So they have some features I'm slightly jealous of. They can do some nice things with durable functions that kind of now you can do a bit with step functions and with Lambda destinations. But stupid things like being able to throttle the rate at which your functions consume a queue, that kind of stuff. So I think Azure's doing pretty well. I've not seen enough of Google Cloud to really judge. I think where AWS have the lead is the integration between Lambda and the rest of their platform. So being able to trigger Lambda functions for all kinds of things. So AWS config, CloudTrail, make really great event sources where you can enable interesting use cases for automating your ops team. So we don't have an ops team at Cazoo. We just have these platform engineers, and really what they're doing is trying to build more intelligence into the platform so that when somebody uploads something, we can check it to make sure it's got all the right tags on it. And if it hasn't, then we can alert or we can roll back or whatever. And so we'll deploy something, we can automatically instrument it and add the alarms and set up all the centralized logging and all that stuff so that we don't have to think about that stuff anymore. It just works. That stuff requires, it's not specifically the functions as a service that have the maturity there. It's the overall platform.
yeah. And There's obviously implementation differences between these. Are there any emerging standards out there that, for portability?
So I'm ish. So I think the thing is that I think that people get quite hung up on vendor locking, and I understand why. But I think that it's to some extent a kind of outmoded way of approaching things, right? So back in 2008 or whatever it was, when EC2 came out and they just leased you a server essentially, and you put whatever you wanted on it, then you could build things in such a way that if you decided you wanted a different vendor, that'd be okay. You just move all of your stuff to a different server, and that would be fine.
Hmm.
But if you're using serverless to its full potential, then you're most likely getting stuck into some of these platform things, right? So you're making use of CloudTrail, you're making use of DynamoDB, you're making use of API gateway. And these are the things on which the vendors differentiate. And if you're trying to work to the lowest common denominator of those, then you're going to struggle, I think. So, I mean, I can't see, maybe it will happen, but I can't see what the incentive would be for Google and Amazon to have a single standard for change data streams between DynamoDB and Bigtable, right? Like, but the thing is that without that kind of change data stream, you're missing out on entire use cases you can enable with serverless, where you can use it for these kind of aggregations and rolling calculations over like big data pieces. So I mean, there's things like cloud events looks interesting, but I think that trying to avoid vendor lock-in will almost inevitably lead you to a lowest common denominator approach, and I think that's possible in a kind of VMs for hire model, but I don't think it makes sense in a true serverless paradigm.
Hmm. Yeah, I get that. You do lose a lot, and especially, I mean, Lambda is so far out there. I mean, they really are, and we're big Google fans at
Yeah,
Commerce Tools, of course, but they really invented this space, and I'm subscribed to all the release notes, and every single day they're making changes.
it's
Uh,
crazy, right?
I'm sure the others will catch up, but it's going to take a little while yet.
Mhm.
There's a lot of buzz out there about Knative. What is that?
So Knative is a set of middlewares on top of Kubernetes that sort of allow you to emulate kind of serverlessness. So it has support for scale to zero web handlers based on Istio. It uses cloud events for kind of pub sub eventing. And I think if you already have an existing Kubernetes cluster, then have at it, I guess. It is supported as a target for the serverless framework, so you can use the same tooling to deploy to Knative if you like. And I've seen some complete maniacs running AWS Lambda functions on it through some kind of weird firecracker emulation trickery.
Yeah,
Um,
right.
so yeah, I think it's probably interesting in like kind of hybrid models, right? So kind of public-private cloud models, or as a transitory step. But I'm not really a Kubernetes fan personally.
Okay, interesting. Um, I like it. So where are we in the hype cycle, right? If you look at the famous Gartner hype cycle, right? Every
Uh-huh.
new technology, there's a trigger, and then
Hmm.
there's overhype, and then it falls into the trough of disillusionment, and then longer term, there's this plateau of productivity where the overhyped thing actually becomes useful. Where do you see serverless right now, just generally as a concept in that hype cycle?
I think we're in the early adopter phase still. I think that adoption for serverless has been slower than for some similarly disruptive technologies. So I started at Made like 5.5, 6 years ago, and at that point, Docker was the next big thing. So we adopted Docker really early on, sort of version 0.8 or something. Um, and then Docker exploded, right? It was very, very quickly deployed. It was an incredibly fast growing technology. Serverless is a much more slowly growing technology, and I think it is because it requires such a fundamental shift in the way you approach your architectures. So I think we're still kind of in this early adopter phase. I think we're yet to see the point of overinflated expectations, just because there is such a kind of high barrier to entry where you have to be willing to change the way you write code in the first place.
Yeah, I agree. No, I very much agree. We're kind of heading up that slope right now with inflated expectations.
Mm.
That's where I see it.
Yeah, and
But
it's happening quickly. But yeah, we're not there yet.
yeah, it's exciting though. But you're right. It's all of these other steps, whether they're from physical machines to VMs to then containers. It's taking something that existed, lifting it and shifting it to something a little bit smaller. And here you can't do that. It's a fundamental rewrite. So I think it's gonna, the adoption cycle here is gonna be a lot longer. But
Agreed.
I do think it's becoming kind of the standard for how you do this. And I know if you look at our platform and others like ours, you customize and extend them primarily through events. And I
Absolutely.
think the more of these SaaS apps you see, I think of event-based or serverless-based customization using events of SaaS is going to be a big thing. And it makes perfect sense. I mean, yeah, I think it's the future. So stepping back a little bit, what's next for serverless?
Lots. So I think we're going to see more niche plays for a start. So there's a company called Zeit who make a React framework called Next.js that does server-side rendering. They've got some tooling that makes hosting these kind of server-side React apps like perfectly simple. You don't need to know anything about how it works. You just deploy your code, just the same way I do with serverless deploy. If you're building like these React SSR apps, you just type now up or whatever it is, and it's just there, right? So I think we'll see a lot more of those, these kind of single technology serverless plays. Because a lot of the software engineering market, whether we like it or not, is kind of marketing sites and landing pages and stuff. All of that could easily move serverless like tomorrow. It wouldn't really much more difficult. So I think AWS Amplify and Firebase are other interesting cases where you can build like an entire mobile app and just outsource your entire back end on a kind of pay-per-play basis. Um, More broadly, I think you're right. We'll see more kind of serviceful computing. So we use Commerce Tools as our e-commerce platform. We use Prismic as a headless CMS. We're interested in maybe using Algolia at some point as a headless search engine, and so on and so on. And I think more and more people will see their architectures begin to look like this, right? Where you've got a bunch of providers who do kind of generic heavy lifting, and then you're really just providing the customization and combining these things in order to provide a coherent experience. Um, and then I guess the next big thing, I see a lot of people talking about this kind of hashtag no code as a hashtag movement, um, where in your example earlier, maybe I can create like an S3 notification for a product image being uploaded, and that goes into EventBridge. Then I've got some content-based routing for that message, and I invoke a third-party function for the resize, and then that writes back into my bucket, and I raise another event message, and so on. And conceivably, I can build that whole use case with that single line of imperative code, but all I'm doing is just configuring the triggers and the mapping. And so for some simple cases, like your web form that captures some contact details or for your image resizing thing, I think we are actually really close to being able to build entirely new applications without actually needing to write any code. Um, I think that's going to be interesting.
Yeah, I could absolutely see that. It's exciting to think about. And just, if you look back 10 years from now, I think people are going to look back on how we built software in the 90s and 2000s and even today and say, wow, that was very different.
Mm-hmm.
It'll be exciting to see. I'm glad we're part of it. All right, with that, we'll wrap it up. Thanks for joining us, Bob, and thanks to our listeners for joining us for this episode. And you can head over to commercetomorrow.com for back episodes of the podcast. Thanks again.
Cool. Thanks for having me.